In this video, I'm going to be going through question 5B and C from section 8.1, which is on page 471 in the textbook. So I have 5B written here. What we're trying to do in this question is we're trying to figure out if these lines intersect, and if they do, we need to find that point of intersection. So the first thing that I'm going to do when I look at these two lines is take a look at the direction vectors. In this case, these direction vectors are not the same, and they're not scalar multiples of each other. So I know that my answer is either going to be a unique solution, or they're going to be skew, so they're not going to intersect at all. So the first thing that I'm going to do is I'm going to rewrite these equations in parametric form. So for line 1, I'm getting x is equal to 3 minus 1s, or 3 minus s. Y is equal to negative 2 minus 2s, and z is equal to 2 plus 0s. And then for line 2, I get x is equal to 1 plus 0t, y is equal to 0 plus 2t, and z is equal to negative 1 minus 3t. At this point, I can go ahead and I can equate some of these. So I'm going to set I guess I'll use red and highlight it. I'm going to set 3 minus s equal to 1 because x is equal to both of those. So my first equation, 3 minus s is equal to 1. My second equation is going to be dealing with the y's. So I've got a negative 2 minus 2s is equal to 2t. And hopefully I can fit this third one in there. Make it a little bit smaller. The third equation is going to be the z's, so 2 is equal to negative 1 minus 3t. When I look at this first equation, I know that I can easily isolate s. So I'm going to have 3 subtract 1 is equal to s, or s is equal to 2. And when I look at the third equation, I know that I can easily isolate t. So 2 plus 1 is equal to negative 3t, and 3 is equal to negative 3t, which means t is equal to negative 1. I didn't do anything with the second equation because it does have both variables, so I know that it would be harder to isolate. If you're not able to isolate in two equations and you're not able to get s and t right away, you will need to choose two of the equations to either use substitution or elimination and solve for those two variables that way. Now that I have my s and t, I am going to go ahead and plug them into my equation 2. And what I'm going to do here is I'm going to be checking if the left side is equal to the right side. If left side is equal to right side, there is a unique solution. If it is not, these lines don't intersect and they are skew. So I will set that up right now. Left side, right side, negative 2 minus 2s, and right side is 2t. Negative 2 minus 2, I'm going to plug that s of 2 in there, and I'm going to get negative 2 minus 4, which is negative 6. And then 2, I'm going to plug that t of negative 1 in there, and I get negative 2. So left side does not equal right side, and therefore these lines are skew, or they don't intersect. All right, 5C is the exact same type of question. We're taking a look at these two lines. We're seeing if they intersect. When I look at these lines, I do notice that my direction vectors are the exact same. So since this is the case, these lines are either parallel or they're coincident, meaning there's going to have a unique or an infinite amount of solutions. Sorry about that. In order to tell what the case is in this situation, I need to choose one of the points in one of the lines and see if it satisfies the second line. If it does, then I know that there's an infinite amount of solutions, and if it doesn't, I know that these two lines must just be parallel but not intersect. So I'm just going to go ahead and I'm going to take this first point, and I'm going to see if it satisfies this second equation. I could choose the second point and see if it satisfies the first. It's the exact same thing. So in order to do that, I am going to turn the second equation into some parametric equations. I think it's a little bit easier to visualize that way. So x is equal to negative 7 plus 2t. Y is equal to negative 7 plus 1t. And z is equal to 20 minus 5t. What I'm going to do now is I'm going to take that point, 7, 0, negative 15, and I'm going to plug it into these equations to see if I can get the exact same t value. So 7 is equal to negative 7 plus 2t. When I solve for this, I get 7 plus 7, which is 14, divided by 2, and I get a t of 7. I'm going to do the exact same thing, plugging in this y of 0. So 0 is equal to negative 7 plus 1t. When I solve this equation for t, I get, again, t equals 7. And the third one, I'm plugging in this negative 15 for my z. So negative 15 is equal to 20, subtract 5t, and when I solve for this, I get negative 35 divided by negative 5, which gives me a t of 7. Since all of these t's are the exact same, I know that there is an infinite amount of solutions. These two lines are the exact same equation.